Now that we have our body created, we need to figure out, does it meet the tipping force and does it meet our criteria for no more than 125 pounds? To do that, we need to assign it a material. So we can go up here to the material browser and then assign it a material. So you can do this in the assembly. That's what we're going to do now. What you need to do is go ahead and click this, and that's going to open up the material browser. And then we're going to go down to wood, okay? And right now we don't really care what kind of wood it is, because basically there's already several types preloaded for you. If that works for you, that's great. But a lot of people want to use pine because it's very common for pine trees to be used in this situation where they've been blown down and they have been cut up. Also, a lot of times people over design this and they need a lightweight wood, and pine, being a soft wood, is lighter in density than these, which are all hardwoods, which tend to be denser. So we have all the wood sections down here. To make your own, right? So we're going to add pine. We're going to make our own. So what we're going to do is we're going to start with birch. That's probably the least dense one. We're going to change it. It doesn't really matter, but it also has a nice picture and I like it. So we're going to right click here and then say add to document materials. And it's going to take a few seconds and go ahead and load in, and you can see it's a document material. So I can click that and then I can say edit. All right, and then it is going to take a few moments and it's going to pull itself in, and this will actually take a little while. Okay, and you'll notice it says it goes and changes. So we're going to call this wood, and we're going to say this is pine, and it took a few minutes there. So we'll say this is pine, and it's a type as a wood and so forth. And we can look at the appearance, we don't care, and then we can look at physical. And when you go down to physical, open up mechanical, because here is the density. So we need pounds per cubic inch. Pounds per cubic inch. Your units are extremely important. So we need to go do a Google search for what is the density of pine, or white pine to be exact. So if we look here, here is white pine. I just did density of pine. All right, white pine, it is 22 to 31 pounds per cubic foot. All right, if we go back over here, I need pounds per cubic inch. How do I do that conversion? Well, luckily, all right, you can get that however you want. I highly suggest that you take, 30. All right, you don't want to pick the low end. Okay, you want to pick the upper end. If you're saying it's white pine, you want to give yourself a safety factor. And so I would do like pounds per cubic foot to pounds per cubic inch, and Google will tell you what that is. So pounds per cubic foot, 1 pound per cubic foot into pounds per cubic inch, and you can see there is the answer. We need 30 pounds per cubic foot. So we just go here and type 30, and then so that is 0.017. That's probably enough significant digits. Or we can sit here and just copy this whole thing. All right, so we're going to copy this, and then we're going to go back into Inventor. Okay, and so from here we're going to paste that into Inventor. So there's my pounds per cubic inch. You see it rounds it to 0.017. Hit apply. Now, you can't do, if you were going to do FEA analysis on this, you would have to change all of these. But really, all we're looking at is density. That's all we care about. We hit apply. We're all good. Okay, hit cancel. I want to double check that because I think cancel is weird. So let's make certain. Let's go in here and let's say edit. And then let's go into physical and give it a second. It's got to find its way again. So go into physical, look at mechanical. It did save that. So cancel is its normal operation. That just seemed weird to me. And then we can exit out. So now we have these parts that don't have any material assigned to them. Okay, so then I could say, you know what? I want this material, instead of being generic, okay, it needs to be wood pine. And then this one needs to be, instead of generic, needs to also be wood pine. And you'll notice these are all 4 identical parts, so they all changed at the same time. Now, no, this doesn't look like wood. or it doesn't look like pine wood. I didn't change the appearance any. I think it probably kept the default one. I thought it's copying birch, but it looks kind of dark for birch. And so that has the density applied to it. And if we go and we look at our eye properties, we go to physical, all right, and we update. Okay, you can see that it's converted that density into this, and we can see that our item here is 170, basically 180 pounds. That is over the 125 weight limit. So I'm going to have to go and modify my design to get it under that weight limit. And there's different ways you can do that. So we could go and, so that's how you, let's say this is how you make your own material and adjust the density. So if you want to make something lighter weight, less dense, if you can find a local wood that works for that, I doubt it, but I think pine is probably it, but go and look, maybe that's true, or maybe it's not. And so you could change the type of wood, and that's going to change the density of, or you're going to need to change, so you can change the density, or you need to change the physical shape of the object. Okay, so I can go and I can say, you know what, I'm going to take this, I'm going to open this up, and I'm going to make it not quite so long. And so let's say this, we're going to edit this feature. All right, I'm going to make it 24 inches long. Okay. And so when you do this, things might change because I may have things overlapping. So I'm going to just hit accept and see what broke. All right, so this extrusion it's having trouble with. And you can see that, oh, okay, so I moved it backwards. And this is the one, if you remember the video, I didn't dimension it. And if I had, it probably would have worked just automatically because I didn't put a dimension on it. So if I edit the sketch and I bring it back here, move for me. And I bring it back here, and I say, you know what, I'm going to put a dimension so I can go ahead and project this geometry up to there. All right, and then I can say, you know what, make me a dimension between here and so I'll put a point where that intersects right there, and then I can say from here to here, I want that to be 3 inches, and that's where my neck is going to go. You can see that it says it still needs 2 inches. Okay, so that will move. So I can say, you know what, I want this to be horizontal, so this to be horizontal at this point, and that's going to constrain the sketch. I'm not exactly certain why. That shouldn't, unless this and this. It's one of those tricky ones where it thinks, oh, I actually hit. Interesting. So let's do this from here to here, and then we'll say this is horizontal. I don't know why that is over constraining the sketch, unless that is not the origin. Interesting. So we're going to leave it there. That way we can keep the video going. We can go back and try to figure out what is going on there. If we attach it from, if we say horizontal between this line and this, so that's it. So this is actually the center point of that. So then now that that is tied in, I don't know what's going on. It could be one of those, every now and then Inventor does weird stuff and you need to so let's edit this extrusion. So edit the feature. So we're not going down far enough. So we'll give it a little bit of distance there. And then now that updates that. And so then we will, I don't want to save it because I like the other one better. And then let's go ahead and update this. So local update. All right, so that's going to move the legs, and you'll notice that all of the, because I didn't, so let's go and edit the legs. So here's what happened. These all updated like they should because we built there. When we did this one, something has went wrong, and so we just need to go and oh, you know what? I wonder if we did a global update. So go back here. Let's try global update just to, Oh, nope, it updated everything. So let's go back and let's go back and look at the leg. Let's see what's going on with this sketch here. So I didn't constrain it. All right, so let's say this is concentric around this, which is the way I probably should have done it from before. That has a constraint on it, so let's open up our constraints, show all constraints. I have some sort of constraint there. I want this to be constrained. There we go, which is how I should have done it to begin with, but you know, when we do these videos and it's very fast, we screw things up. And so we go there, and then we'll go back to our reindeer, and then now our reindeer is back together. But let's go back to the leg and make it not quite so long. And so let's edit this feature, and let's say this is 12 inches high. Now, you will have some, you know, we probably to do this to keep it proportional, we would probably have to go ahead and make the body not quite so round, because now this is looking definitely pig-shaped and not deer shape. So let's go ahead and fix our proportions a little bit. So let's edit the feature there, and let's say I think we were 24. Let's go to 18, and then go back to our reindeer, and you can see that it's updated. And then now let's go eye properties, physical update, and now I am 121 pounds. So now I'm under that cutoff just barely. All right, and our deer is looking pretty good. Now yours, 125 pounds, counts the head and neck. I don't have that in here, so I would have to go back and make some more massaging to that. But that is how you create your own material and get your density just right. And then if you need to tweak it, an example of a long-winded example of how to, you know, some approaches to go to change it and make it be underneath the 125 limit.